हेलो एवरीवन, आज हम लोग देखेंगे वेक्टर और क्रॉस प्रोडक्ट. सो इफ a vector and b vector be two non-parallel vectors, then the vector product a cross b in that order is defined as a vector whose magnitude is mod a mod b sin theta, where theta is the angle between a and b and whose direction is perpendicular to the plane of a and b in such a way that a and b and this direction constitute a right-handed system. So if we define a cross b, that should be mod a mod b sin theta. This is the magnitude, and there should be a direction. Let us say this is n cap. So if we see it graphically, then it would be, let us say, this is a plane where a and b resides, where a and b resides, and angle between a and b is theta. Okay, this is the plane where a and b vector lies, and there is a normal vector out of the plane. This is your n vector, and this n vector, this n cap is perpendicular to both b and both a. Okay, so this whole system is known as a right-handed system. Okay, now when we say ab and n cap form a right-handed system, it means that if we rotate vector a into the vector b, then n cap will point in the direction perpendicular to the plane of a and b, in which a right-handed screw will move if it is turned in the same manner. So, or you can apply here right hand thumb rule. If you move your fingers from A to B, your thumb will point in the upward direction, and that would be the uh, direction of A cross B. Okay. Now let us see some points. See if one of A or B, if one of A or B or both is 0, both is 0 vector, then theta is not defined. Then theta is not defined. Okay, as 0 vector has no direction. Okay, so n cap is not defined in this case, and we can say A cross B would be a 0 vector. Point number 2, if A and B are collinear, if A and B are collinear, that is angle between A and B is either 0 or pi, that is the two vectors are parallel or anti-parallel, then in this case also direction n vector is not well defined. So in this case we can say, because they are parallel or anti-parallel, sin 0 is 0 and sin n pi is always 0. So you can say A cross B is 0 if the two vectors are parallel or anti-parallel. Next point, see A vector, A cross B vector, here we can see we have a direction. That's why it is known as vector product. It has a magnitude and a direction. That's why it is known as vector product. Okay, it is known as vector product because it has a magnitude and a direction. Next, if you want to see the geometrical interpretation of vector cross product, so let us see geometrical interpretation of vector product. So let us see one diagram where A vector and B vector constitute the side of the parallelogram. Okay, if we draw in this manner, then it will constitute a parallelogram where this B vector, so this would be B vector, and if this is A vector, then this would be A vector. And there is a direction vector perpendicular to both A and B. So this is your n cap. Okay. Now angle between A and B is theta. If we draw a perpendicular here, then this perpendicular would be mod of B sin theta. Okay, and this component would be mod of B cos theta because this component is attached to vector B directly. So if we give a name O A B C and this point as L, so we can see that O A vector and OB vector are non-parallel vectors, and theta be the angle between them. And from this parallelogram OACB, we have to draw a perpendicular BL on the side OA. So from this triangle OBL, this triangle OBL, we can say sin theta is opposite by hypotenuse, that is BL by OB. So we can say BL is OB sin theta. Now OB is the magnitude, so it is the magnitude of B into sin theta. Now we know that A cross B is mod A mod B sin theta into n cap. So putting the values, mod of A vector, that is side OA, mod of B vector, that is side OB, that is side BL, sorry, this is side BL, and unit vector. Okay. Now here we have put the value mod of B sin theta, this mod of B sin theta, this is our BL, right? Now this OA and OB, this OA is your base, this OB, this BL is your height, base into height into n cap. So base into height is your area of parallelogram. So you can say this is area of parallelogram OACB multiplied with direction vector. Now this is called vector area. This is called vector area of the parallelogram OACB. This is vector area because if we take this area, then unit vector is always outward normal, right? So A cross B is a vector whose magnitude is equal to the area of the parallelogram, having A vector and B vector as the is adjacent sides, and its direction is along n vector n cap, that is perpendicular to both A and B. Okay, such that A vector, B vector, and this n cap forms a right-handed system. Okay, it is known as right-handed system because if you move a screw from A to B, it will uh, proceed in the vector n cap. Okay, now so you can say area of parallelogram, area of parallelogram OACB is mod of A cross B. Now, if we want to find the area of triangle, so you can see area of triangle OAB is half of area of triangle. Let me draw the diagram. If this is your B vector, this is your A vector, then first complete the parallelogram. This is the parallelogram, and if you join this side, this perpendicular is your mod of B sin theta. Just now we have seen. This is your angle theta. Okay. Now area of, let us name this OABC. So from this diagram we can see that area of triangle OAB is half of area of parallelogram OACB. So this should be half of A cross B. So remember this. We can find the area of triangle constituted by the sides A and B, and those both sides should be adjacent, making an angle theta between them. By the term vector area of a plane figure, we mean that a vector of magnitude equal to the area of the plane figure and direction is outward normal, and it forms a right-handed system, that is right-handed rotation. Now if we see the properties of vector product, if we see the properties of vector product, then property 1 is A cross B is minus of B cross A, because when you move from B to A, then your thumb will in the downward direction, so it will be minus of B cross A. So A cross B is minus of B cross A. Property 2 is if A and B are two vectors and M is a scalar, so M into A vector cross B vector, you can take the scalar outside, or you can adjust the scalar in any of the vectors. So A vector cross M into B vector. Okay. Now our third property is if A and B are two vectors and M and N are scalars, then we can say M into A vector cross N into B vector is m into n, a cross b, that is m into a cross nb, or n into ma cross b. You can adjust the scalars with any of one of the vectors, or you can keep outside. Okay, this is the property. Property number 4 is, this is distributive property over a vector product over a vector addition. So let us say a b c are three vectors. Then we can say a cross b plus c vector is a cross b plus a cross c. This is left distributivity. And if we say we have b plus c cross a, then this would be b cross a plus c cross a. This is your right distributivity. Now our property number 5 is, if we say we have three vectors a b c, then a cross b minus c would be a cross b minus a cross c. Okay. Now property number 6 is, we say a cross b is 0, that means a and b are parallel or anti-parallel. That this implies and imply by a is parallel to b. Okay, those vectors are parallel vectors. So in this manner we can say that similar product, that is similar cross product, that is a cross a, is always zero vector because they are parallel vectors. And if we say I cross I, that is I cap is along unit vector is along x axis, so you are making the cross product of the same vector, that is their parallel vectors. So I cross I would be 0, j cross j would be 0, and k cross k would be 0. Okay. Now if you want to see vector product in terms of component, vector product in terms of component, so let us say we have a vector as a1 I cap plus a2 j cap plus a3 k cap, and b vector as b1 I cap plus b2 j cap plus b3 k cap. Then a cross b you can find out by the determinant. You have to write in this way: I cap, j cap, k cap, and write the coefficients a1, a2, a3, b1, b2, b3. Okay, that's how you have to write it down. Or you can simply find the cross product, that is a1 I cap plus a2 j cap plus a3 k cap cross product with b1 I cap plus b2 j cap plus b3 k cap. If you say this is your I, this is your j, and this is your k, then move in clockwise direction. So a1 I cap cross b1 I cap, so it would be 1 into b2, a1 into b1. Next is a1 I cap cross b2 j cap, so it would be a1 b2 I cross j. So I cross j, that means you will get positive k. And in case if you get k cross j, and if you are moving in the anti-clockwise direction, then it would be minus I. If you are finding out j cross I, then you are going in the anti-clockwise direction, so then it would be minus k. Okay, remember this. But the best method would be to find out the cross product by determinant. Now our next topic is vectors normal to the plane of two given vectors. So we already know that in the case of a cross b, the unit vector, the direction vector n cap is normal to the plane. So we can say a cross b is mod of a mod of b sine theta is a magnitude and a normal vector n cap. So from this is the magnitude, right? So we can say this is modulus of a cross b multiplied by n cap. So from this we can find out the normal vector as a cross b divided by modulus of a cross b. So remember this is very important. Normal vector is a cross b by modulus of a cross b. Okay, and this is a unit vector perpendicular to the plane of a and b. And now we will see some important result. We have just seen that area of parallelogram with adjacent side as a and b is modulus of a cross b. Area of triangle with adjacent side a and b is half of mod of a cross b. Okay, and see area of triangle. If you have a triangle, area of a triangle ABC, you can take it in any order, that is half of mod of AB cross AC, or half of mod of BC cross BA, or half of mod of CB cross CA. Okay, next point is area of parallelogram. Area of parallelogram with diagonals A vector and B vector is half of A cross B. If you know the diagonal, of a parallelogram, let us say this is your A vector, this is your B vector, then area of this parallelogram would be half of A cross B. Okay, remember this. This is very important. Now, if we extend our knowledge, then the area of plane quadrilateral ABCD, let us say our quadrilateral is in this format. This is your any quadrilateral. Then the area of quadrilateral this ABCD is half of multiplication of similar in this manner, half of AC cross BD. That means multiplication of the diagonals, cross multiplication of the diagonals. Okay, remember this. Now our next topic is Lagrange's identity. Lagrange's identity is A cross B square plus A dot B square is modulus of A square modulus of B square. This is what is Lagrange's identity. Okay, remember this. Modulus of A cross B square plus A dot B square should give modulus of A square into modulus of B square. Now let us see some question. So our first question is, if R vector is xi cap plus yj cap plus zk cap. Okay, now this is zi cap given. Find the value of R cross I dot R cross J plus xy. You have to find this value. Okay, now before that you have to know, let us say we have vector A vector as A1 I cap plus A2 j cap plus A3 k cap. Then A cross I would be A1 I cap plus A2 j cap plus h3 k cap cross I. That means see I cross I is 0. So we have to find out j cross I. So if we say I j k, then j cross I, this is minus k. So it would be minus a2 k cap, and k cross I is plus j cap. So it would be a3 j cap. Okay. And if we want to find this question, so here I can say that r cross I, we have to find out r cross I. So r cross I would be, r vector is x I cap plus y j cap plus z I cap, cross product with I vector. Then see I cross I is 0 because sin 0 is 0. And if you multiply j cross I, so j cross I would be minus k. So it would be minus y into k, and this should be j. There is a mistake in the question. This should be j. This should be k. So minus y cap, y k cap, and k cross I. K cross I is j. So it would be z j cap. Okay. Now remember, now write this in the standard form. It is 0 I cap plus z j cap minus y k cap. And we have to find out r cross j. So r cross j would be, r vector is x I cap, y j cap plus z k cap, cross multiplied with j cap, we will get I cross j. I cross j is k cap, so x k cap. J cross j is 0, so 0 k cap. Okay, we'll write it later. Now k cross j. K cross j is minus I, so it is minus I z minus z I cap. So we have j cross absent, j vector absent. So writing it in standard form, z I cap plus 0 into j cap plus x into k cap. Now we have to take the dot between these two vectors. So r vector cross I cap dot r vector cross j cap. We have to find the dot product between these two. That is 0 I cap z j cap minus y k cap dot product with minus z I cap plus 0 j cap plus x k cap. Now if you see, I dot I is 1, j dot j is 1, k dot k is 1, I dot k is 0, right? Dissimilar product is 0, similar product is 1. So I dot I, that will be 0 because here a component is 0. J dot j, this will be 0, 0 multiplied by z is 0. and k dot k is 1, so you'll get minus x into y. So you have to find out the value of this thing. So you got this is as minus xy and plus xy is there, so it would be 0. So value of this is 0. Okay. Now let us see another question. Show that the area of a parallelogram having diagonals 3 I cap plus j cap minus 2 k cap and I cap minus 3 j cap plus 4 k cap is 5 root 3 square unit. Just now we have seen that area of parallelogram when the diagonals are given, we can find it by cross multiply the vectors a cross b. So this is I j k. Then we have to write down the component of a first, 3 1 minus 2, 3 1 minus 2, and then b, that is 1 minus 3 4. So 1 minus 3 4. So let us find out. Let us expand along first row. So it would be keeping I 4 minus of minus 3 into minus 2, that is plus 6. So 4 minus 6, that is minus 2 I cap, and j sign is minus, plus minus plus. So minus j, omitting this column and this row. So into 4 12 minus of minus 2 into 1, so plus 2, so 14. So we'll get minus 14j, and k, omitting this column and this row, it would be minus 9 minus 1, that is minus 10. So minus 10 k cap. Now area of parallelogram is modulus of this. So modulus of a cross b, that is square root of x square plus y square plus z square, that is minus 2 square plus minus 14 square plus minus 10 square. So this is root under 300. Okay. Now area of parallelogram is half of this. Area of parallelogram when diagonals are given, that would be half of a cross b, mod of a cross b. So area of parallelogram is half of modulus of a cross b, that is half of square root of 300. You calculate 3 into 100, that is 10 will come outside, 10 by 2 is 5, so 5 root 3 square unit. Okay. Now let us see another question. Find the area of the triangle whose vertices are a 3 minus 1 2, b 1 minus 1 minus 3, and c 4 minus 3 1. We have to find the area. So let A vector, B vector and C vector be the position vectors, be the position vectors of points A, B and C. Then position vector is always calculated from origin. So if we say A vector, that would be 3 minus 0, that is 3 I cap. So it would be 3 I cap minus 1 j cap, that is j cap, plus 2 k cap. Similarly, B vector would be I cap minus j cap minus 3 k cap, and C vector would be 4 I cap minus 3 j cap plus k cap. So area of triangle ABC, area of triangle ABC, that would be half of modulus of AB cross AC. We have seen this, right? So what is AB vector? AB, that is final minus initial. So B vector minus A vector. So B vector is this, A vector is this. If you subtract B vector, A vector from B vector, we'll get I minus 3I, that is minus 2I, and minus J, minus of minus J, that is 0. So you'll get 0 J cap, and minus 3K minus 2K, that would be minus 5K. Okay, so this would be minus 5K cap. Now if we find out AC, then final minus initial, so C vector minus A vector. So we have to subtract A from C. So 4I minus 3I, that is I cap, minus 3J minus of minus J, that is plus J, that is minus 2J cap, and K minus of 2K, that is minus K cap. Now we have to find out first AB cross AC. Okay, this is a triangle where the vertices are given. Let us say this is ABC. So you have to take adjacent side, right? So we have taken AB and AC. You can take BC and BA. You can take CA and CB. You have to take adjacent sides. So it would be by determinant we can solve it. So our this is I j k, and AB vector is this. So minus 2, 0, minus 5, and AC vector is this. The component is 1, minus 2, minus 1. So if you calculate, you will get it as minus 10 I cap minus 7 j cap plus 4 k cap. Now you have to take modulus. So AB plus AC would be square root of minus 10 square plus minus 7 square plus 4 square. So it would be root under of 165. And area of triangle ABC is half of modulus of AB cross AC. This would be half of square root of 165. Okay, that's how you have to solve this type of question. Now let us see another question. prove that the normal to the plane containing 3 points whose position vector whose position vectors are A, B, and C lies in the direction B cross C plus C cross A, C cross A plus A cross B. Okay, so let us see the solution. So first of all, let A, B, and C be the points having position vectors having position vectors A, B, and C. Okay, then we know that if we take adjacent sides, then AB cross AC is a vector normal to the plane containing the points containing the points ABC. ABC. Okay, now we don't know where the points are. Let us say this is your AB, this is your AC. These points lie in this manner. Let us say ABC. So if you take AB cross AC, then these 3 points lying in this plane, then they are perpendicular. That is A cross B is outward normal, right? And you have to find that normal to the plane, this plane. So let us find it out. So AB cross AC, AB, that is final minus initial. Position vectors are given. B vector minus A vector cross AC means final minus initial. C minus A. Okay. Now by distributive we can say B cross C minus A, B cross C minus A minus A cross C minus A, A cross C minus A. Okay, but then distribute it again. So it would be B cross A, B cross C minus B cross A minus A cross C minus minus plus A cross A. Now A cross A is 0. We know this. Similar cross product. So it would be B cross C, and we know that A cross B is minus B cross A, so we can write it as A cross B, and A cross C is minus C cross A, so we can write it as C cross A. Okay, now this is the value we have to find out: B cross C, C cross A, and A cross B. Okay, so it's a vector. normal to the plane containing points A, B, C. Okay, this is the vector. Now let us see our next question. That is this: if A vector is I cap j cap plus k cap, C vector is j cap minus k cap, are given vectors are given vectors, then find a vector, then find a vector B vector satisfying the equation A cross B C equals to C vector, and A dot B is 3. So let us see this answer. Let us see the answer. So we don't know the B vector. So let B vector in the component form xi cap, yj cap, and z k cap. So it is given A cross B equals to C. So A cross B equals to C vector. So A cross B, we can find it out by determinant. So I, j, k. A vector is this, component is 1 on 1. Magnet, and B vector is xyz. So xyz. Now what is C vector? C vector is j minus k cap. So let's find out the determinant. So it would be z minus y I cap minus z minus x j cap plus y minus x k cap. We can write it as 0 into I cap plus j cap minus k cap. So comparing both the sides coefficients, we can say z minus y, this is I, this is I. So component I component is 0 and it is z minus y. So z minus y is 0, and minus of z minus x is 1, and y minus x is minus 1. Okay. So from this we can see that z and y are same, and this is, we can say, x minus z. If we take minus common, so we can say x minus z is 1, and if we take minus common, so x minus y is 1. Okay. Now z is y, and we put the values here. X minus y, this is 1, and here also x minus y is 1. Okay, but this will not work. So let us say z is, here z is x plus z is x minus 1, z is x minus 1 and y is x minus 1 also. Y is x minus 1 also. So it is given that A dot B is 3, right? We know A vector, that is I plus j plus k, and B vector is xi cap, yj cap, zk cap. So it is I j k dot xi cap, yj cap, and zk cap, that is 3. So similar product is 1. So it would be x plus y plus z, that is 3. Now put the values. X, y is x minus 1 and z is x minus 1, that is 3. That is 3x equals to 5. That means x is 5 by 3. So if we put y is x minus 1, that is 5 by 3 minus 1, that is 2 by 3. So similarly, we know that y is equals to z. That means z is 2 by 3. Y is 2 by 3. So that means z is 2 by 3. Okay. Now we find out the v vector as 5 by 3 I cap plus 2 by 3 j cap plus 2 by 3 k cap. This is a vector that is required. Okay. So जो यहाँ पे क्रॉस मल्टीप्लिकेशन का जितना प्रॉब्लम यहाँ पे हो सकता है हम लोग यहाँ पे किए. नाउ और एक क्वेश्चन हम लोग देख लेते हैं. Let us say this is our last question. If a vector, b vector, c vector are three vectors such that modulus of a plus b plus c is 1, c vector is lambda into a cross b, modulus of a vector is 1 by root 2, modulus of b vector is 1 by root 3, and modulus of c vector is 1 by root 6. Find angle between A and B. This is the question. So let's see the solution. It's given that C vector is lambda into A cross B, and C vector is some constant multiplied by A cross B. That means C is a perpendicular vector, right, to both A and B. So from this we can say C is perpendicular to both A and B. Okay. So if C is perpendicular to both A and B, we can say that C dot A C dot B should be 0 because it's a dot product should be 0 as the vectors are perpendicular. Okay, we know that if A and B vectors are these, then this should be A cross B. So it is along the normal vector. So C vector is perpendicular to both A and B. Let theta be the angle between A and B. It's given that modulus of A plus B plus C is 1. So modulus of A plus B plus C is 1. So squaring both sides, we get A plus B plus C square, that is 1. So what is A plus B plus C square? That is A square, that is A dot A, that is A square plus B square plus C square plus twice AB BC CA. So A dot B, B dot C and C dot A. This is 1. Modulus of A is given 1 by root 2. So this would be 1 by 2. Modulus of B is 1 by root 3, that is 1 by 3. Modulus of C is 1 by root 6, that is 1 by 6. Plus twice CA dot B is mod A mod B cos theta. So you can write it as 1 by root 3, 1 by root 2 into 1 by root 3 mod A mod B cos of angle between them. What is B dot C? B dot C, that is mod B mod C cos theta, but B dot C is 0. C dot A is 0. So both of the component is 0, that is 1. So from this you can say this is 1 by 6 plus 1 by 3 plus 1 by 2 will constitute 1, 1, 1, 0. This whole term will go on that side, it will be 0, so cos theta is 0. So that means theta is pi by 2. So angle between A and B is pi by 2. This is the answer. So I think तुम लोगों को समझ में आ गया होगा वेक्टर प्रोडक्ट और क्रॉस प्रोडक्ट. सो कमेंट करो तुम लोगों को नेक्स्ट चैप्टर कौन सा चाहिए और किस लेवल का प्रॉब्लम तुम लोगों को चाहिए. फिजिक्स केमिस्ट्री मैथ कोई भी चैप्टर का वीडियो तुम लोग बोलोगे हम तुम लोगों के लिए बना देंगे. ओके, सी यू नेक्स्ट टाइम. हैव ए गुड डे.